Hello and welcome everybody to today's episode of Red Hat's series of webinars around containers. I am Lars Hermann. I'm responsible for integrated solutions at Red Hat, and I'm going to give you an overview and introduction about how to revolutionize application delivery with containers. With that, let's dive right into it. Why do we talk about containers so much in the industry? The primary reason is the context in which we are as an industry. We are in a massive shift towards the digital business in which IT no longer is supporting the business, but increasingly becomes the business, and therefore the requirements and demands on IT are changing at a very rapid pace that many of us have never seen before. From a technology standpoint, these demands quickly translate into systems that are flexible, that can be scaling up and down demands, so they are inherently distributed. And distributed systems have their own set of challenges and problems because they are complex and they need a different approach to manage them. At the same time, we also live in a world in which applications are increasingly driving the business value that an organization can create and achieve. So application development and enabling developers to rapidly introduce new releases and new features to the market becomes of critical importance, which most organizations respond to by empowering their developers and introduce a new set of IT processes that are effectively built around decentralization. Now, all these things are changing. Containers are one of the key technologies, along with other technologies around cloud and big data, that are driving that shift and that become an important tool in the toolbox of an enterprise IT organization. That said, there's a lot of discussion in the market about containers and what are they for and how can they be used and how can an organization be successful with it. At a high level, there is of course also confusion and misconceptions about containers. What I hear a lot are these 5 conceptions that you see on this slide. It starts with containers are really not new. We have been doing containers at Red Hat for almost 10 years in one way or another. And in fact, containers go back to Unix and even the mainframe. So the concept of taking an operating system instance and slicing it into multiple execution environments for application code with some degree of de-isolation is not new. What is new in today's discussion about containers is the context in which we want to use them, which are distributed applications on distributed environments, as well as the focus on application development. So we look at containers not so much as just an infrastructure paradigm to increase efficiencies and densities, but rather as a method to deliver applications with a greater degree of flexibility, but also portability and agility across the organization, which is similar to what we have done with virtualization, but containers and hypervisors are fundamentally different in how they achieve multi-tenancy in an environment. In virtualization, we are effectively virtualizing physical resources into a software-defined infrastructure layer. Containerization nicely lives on top of virtualization and provides the application environment and all the technologies around application packaging, change management, inspection that are necessary to manage the application lifecycle in a very, very efficient way, as we will see. Of course, there is a promise that applications packaged in containers become very portable. And that is true if all conditions are met. Typically, as we will see later, containers are still carrying a portion of the operating system together with the application code. So a container image is never as portable as a virtual machine is because there is no virtual hardware environment to rely on. It still runs on the operating system that powers the container. And 2 critical aspects of enterprise adoption, which are security and enterprise readiness, are in question around containers, and there is a maturity question. A lot of the technologies around security are fairly new and are changing very rapidly. So I'm going to give insights here today about how to think of security of containers and also how to think of what is required to run containers in the enterprise. Let's begin with the dynamic in the organization, because as I said, containers very much lives in the intersection between the application side of the house, developers, and the IT operations side of the house. In most organizations, there is some degree of tension between these 2 groups in the form of one group depends on the other, or one group feels like developers feel maybe that the IT ops team slows them down or restricts their choice. And we see all these symptoms. And of course, we have a large conversation in the industry around DevOps as a new organizational and cultural approach to bring these two groups together. What is interesting to understand is containers really resonates with both sides of this. And this is one of the reasons why we see so much excitement about it. But we also have to recognize that these two groups are fundamentally driven by different goals. Developers are driven by creating value, creating innovation, creating features. So it is all about speed, it is about choice, and it is about the right set of tools. Whatever gets into the way, whatever slows them down, whatever limits their choice is therefore bad. Now, if you put yourselves into the shoes of an IT ops person, you look at a different set of goals because you manage many applications. And of course, an IT organization is driven by the overall security across the entire landscape, across all the applications, the cost profile and the efficiency to manage many applications in parallel. And of course also the organizational maturity in following procedures that allow complexity to not become overwhelming in the organization. So there is a fundamental conflict or tension between the goals, between these two different groups, and containers can actually help overcome that because they create a very natural way for these two sides to work together where each side of the house can focus on what is most important to them without getting into the way of each other. Now, that said, when we asked our customers together with Forrester about how important are certain benefits around containers, we find that view reflected. So you see, if you look at this chart, better security, increased efficiency, greater application portability across different environments like dev, test, production, but also the ability to deliver and deploy faster. These are all values that speak to both audiences. It is about the developer and it is about IT ops. And this is the reason why we see so many organizations looking at containers to actually drive innovation in the organization, and why we have a very rapid adoption curve. 2 years ago, we didn't really talk about containers. Now it is the hype topic, and 2/3 of all IT enterprises, according to this survey, are looking to be in production in just 2 years. That is a very rapid curve. Now that said, we also talk about a lot of technologies that are not in place in the enterprise today. Some of them are still emerging very, very rapidly and driving a lot of innovation. So there's a set of requirements that are necessary to be successful with a container or container-centric project and initiative in the enterprise. And many of these requirements come down to the fundamentals of any enterprise IT project, which is around a secure and reliable foundation on which to run and build all these stacks. But it is also about the tools that are necessary to orchestrate across many applications and be on top of the game and manage all the aspects that are necessary in the environment. When we asked our customers in the study I referenced earlier about what are the challenges that you see today, then very consistently the number one concern we get from customers is security. Security not only in the risk that is particularly introduced maybe by containers and containerization, but security has across the board risen to one of the top concerns of IT executives. We read about compromises and security flaws in the press all the time, and we read about the business impact that can have. So security is certainly the top concern, followed by performance, which we see are typically just associated with the newness of the technology and the lack of experience with them. There is actually a pretty robust view on the performance of a containerized infrastructure, and I will explain why. And then we go straight into the complexity of a containerized world, which comes down to integrating it into existing environments and the tools to manage the lifecycle, the security, the scalability. So these are the concerns, and when we think about bringing containers into the enterprise, we need these challenges addressed in a programmatic way so the adoption can be safe and easy. If we look at the technology, what are containers? How do they actually work? Then containers really should be thought of as taking the operating system as we know it, which fundamentally delivers two functions in the traditional sense. It lights up a hardware environment, and then it provides an execution environment for applications by providing the core libraries, and the operating system is the technology in the middle. that exposes APIs to the application and runs hardware through drivers and hardware support. In a containerized world, these two functions are fundamentally still there. They're just split into two pieces. There is the container host OS, which lights up the hardware and enables containers to run. And then there's the container itself, which carries the runtime component of the operating system and the application code in a single deployable unit. And what makes containers so exciting is the ability to run multiple containers, multiple applications on the same host without having to require and standardize the runtime environments inside these containers. And this is, in essence, the fundamental new thing that containers introduce. There is a choice that is created for application A or application B, which libraries, runtimes, and frameworks they want to depend on, or which version they want to depend on, which translates to when a change occurs can be managed independently for one application from the other application, which translates to flexibility and freedom to the developers. What we also see on this chart, of course, is what is a relatively simple picture on the left now has become a lot more complicated picture on the right. We have the operating system on the right side of this chart in three places. We have the host operating system, which powers the containers, which needs to be managed. And we have the operating system in both containers shown on this. In the real world, of course, we will look at way more than two containers. So this complexity needs to be managed. And in order to illustrate how this works, let's look at the most interesting application in the world by a simple definition, which application gets written the most. And the one I could find when I did a bit of research is, you guess it, you can see it here, Hello World. Now, the promise of containers is an application, in this case Hello World, can be written in any language, can be packaged in a container, and then run on different kinds of infrastructure. And that is the promise. And that's why developers are so excited, because it creates a unified tool for them. It creates freedom for them, which language to use, which libraries to use. The deployment method in the end is always going to be the same, which is the container, which is also creating a lot of value and benefit for the IT side of the house, because they no longer have to care what is inside these containers. They just optimize for manage these containers. That's what you would think. Let's look at how this really works. In order to run this application, we are actually not done with just the source code. Each of these examples, the simple Hello World example written in different programming languages, depends on a number of runtime components that go into these containers. In the case of a bash script, it's just bash and glibc and maybe some system libraries. In case of the Java, we have a JVM, which depends on a lot of system resources and libraries, et cetera, et cetera. And if we look at these runtime components, the first important thing to recognize is these components typically come from the operating system and other sources, like middleware, JVMs, et cetera. So a lot of it at the core is operating system resources. And we know that the security of a deployment often is defined by the operating system. And that is no exception in the container world. As you see here, a little analysis we did with RHEL 7 being in the market for 1 year, for the simple Hello World example, how many security flaws, important or critical, have we made available for these components within the time frame of 1 year, almost a year? And as you can see, the numbers vary quite a bit, but on average, there is a security issue, even for the simple application that we show here, on average every other week. What this means is your container is going to change every other week, completely independent of a change to your source code. And this is a very simple application, Hello World. A real application typically is more complex and depends on more components. So when we think about managing containers, managing the security of containers, we have to think holistically about all the components that go into the containers. The security of a containerized deployment is predominantly defined by what's inside the containers. And this is why ops can be afraid of containerization being brought in, because all that complexity, all these different choices that developers now can make, how are we going to manage this? And in fact, when we look at container images that are out in the wild, like here you see a study from a third party about who did an analysis about publicly available container images on a public repository. They were simply analyzing of the images that were there, official images in this case, how many of them have medium or high security issues in them. Meaning, if you would just consume and run this container, you effectively run a security risk with them. And the stunning number was that 2/3 of these images that you would download, 2/3 of all the images that are available in that category have at least medium security issues. So just consuming a static container image from somewhere and run it is obviously not going to be good enough. So we need a better solution to do this. Red Hat introduced a number of technologies and services to the market in support of container adoption. And one of the very important ones is container certification. Container certification delivers the promise of containers a customer can trust. And trust is defined along multiple dimensions. Trust is defined as to where do I consume this container from, or who do I consume this container from? Can I trust the source, that the content was not tampered with? Second, it is about what's inside that containers. It is in fact very much what is inside the containers about, is it going to be secure? Is it going to be supported? And is there going to be a path to maintain the life cycle of this? Red Hat introduced to our partner community of independent software vendors a complete end-to-end value chain around container certification, from a container development kit to certification as a service where ISVs can upload their containers. So Red Hat runs tests against that container, which then becomes available to read in a catalog, so customers can see what is available to them for consume, but also integrated in a Red Hat container registry for customers to download these container images directly from their container platform systems, such as RHEL 7. The promise of a certified container is a supported, integrated container based on Red Hat technology inside, therefore benefiting from all the hardening and security maintenance work that Red Hat does for all our platform products, from Red Hat Enterprise Linux to JBoss to software collections to Red Hat storage, you name it. And ISVs can use all these technologies and deliver certified containers. From an end customer point of view, that also creates the opportunity to rely on a unified method to consume third-party applications and services inside their enterprise in a standardized, secure, and trusted way. So this is an important building block for running and managing containers securely. Another aspect is, of course, where do we run these containers? What do we run them on? There is a platform, there's the container host that I showed in the picture earlier, and our vision for container infrastructure is to deliver all the benefits of containerization while at the same time addressing the challenges. When we look at the benefits, then it is all about using containerization as the standard method to deliver applications, package applications. And this might involve existing as well as modern applications that are designed and built for cloud and are cloud native. So it's about modernizing the delivery and introduce more standardization, automation about the deployment of applications. And by doing so, gain agility, enable flexibility and new ways of ownership inside the organization. We also want to enable consistency for an application deployment across different environments, which we very much define based on customer feedback around dev test production on one side. So we can easily create consistency and therefore reproducibility and accelerate delivery across these environments, as well as create flexibility as to where physically to deploy these workloads. At Red Hat, we have the vision of an open hybrid cloud that combines physical and virtual workloads and private clouds on-premise in the data center as destinations that are fundamentally consistent with public cloud resources. So that is about the benefits. Now, I already touched on this. We believe containerization lends itself as a unifying application delivery method, not only for the cloud-native applications composed of microservices developed with scale out and hyperscale in mind. Containerization also is a very important and effective tool to drive more efficiency in IT environments with existing applications. We can package almost any application into a containerized infrastructure and then rely on the security, manageability, and the standardization around these two dimensions for all applications. across the existing ones as well as with future applications that are typically the systems of engagement. What that creates is an interesting opportunity within the organization to redefine autonomy. I already talked about how agility is very much associated with the flexibility for somebody to make decisions independent of other decisions, other groups, other systems. The biggest enemy of agility is a request sitting in a queue and waiting. Therefore, we associate cloud very much with two main concepts. We associate cloud with self-service, so I can go and request resources and consume services and resources when I want to, how I want to, and how often I want to. But we also talk about the concept of abstraction. As a consumer, I should not worry about how the system works underneath. And as an industry, we have defined two definitions that we all try to fit in or try to build on, which is on one hand infrastructure as a service, which abstracts the physical world and creates self-service at the level of typically a virtual machine. So then I can populate the virtual machine with my operating system, my middleware, all the way to my application, and I effectively own this entire stack, everything above the infrastructure as a service platform. We find in many organizations that the value add of infrastructure as a service at scale is not large enough, because it still puts the burden of managing the technology stack that runs the application to the application owner. So we still look at a world where operational requirements like DOS, like security, are in the same, basically, and application code live in the same instance, in this case a virtual machine. On the other hand, as an industry, we talk about platform as a service for a number of years, in which we have a much higher degree of abstraction, where now we not only abstract from the physical world, but we also abstract from the underlying OS and middleware, so I effectively load source code into an environment which then runs the application for me. That is great for a certain kind of applications, but is not lending itself very well to the many existing applications we have, which need some tweaking, some degree of uniqueness about them. Maybe a specific runtime dependency, maybe a specific service they want to consume. With containerization, we now have the opportunity to rethink these definitions and think about a more converged infrastructures in which an organization can freely decide where they draw the lines around ownership. We can draw a line just north of the hardware virtualization layer, but we can draw a second line in the form of container images we make available to developers, where the IT organization can choose to, what are the technology components I make available for my application teams to build applications on, to build containers on, and manage them going forward. And similarly, the application team now is empowered to only own what they should own, and at the same time still retain a lot of flexibility in the decision making. This is one of the opportunities that is created by containers. Now, the second component, when we think about bringing containers to the enterprise broadly across many applications, is interoperability. The less interoperability we have, the more vertical silos we build. And we've seen this movie in the industry too many times to repeat it. Red Hat has been very focused on our entire journey around containers to think of interoperability as a first-class goal. We have defined specifically for containers that interoperability needs to be guaranteed in 4 key areas. It begins with how is isolation achieved inside the container host. And the good news is we have a very mature implementation in the Linux kernel about it. The second layer, and maybe the most important here, is the container format. We have today a quasi-standard with Docker, which is now transitioning into the Open Container Initiative as an open governance foundation-driven format, which standardizes the delivery of container images so that a container image created in one environment can be executed in another environment without any tweaking, modification, customization, or anything. So the format is a critical requirement to be standardized and open, so the format can get better over time without compromising interoperability. The third important layer is orchestration. Orchestration is critical in a containerized environment because, with the exception of my Hello World application that I showed earlier, almost any real application is inherently multi-container. And in fact will be composed of multiple services run in multiple instances for resiliency and performance. Orchestration is the engine in a container stack that now manages the instantiation of the right services with the right resources allocated to them around compute, network, storage on top of a distributed environment. So the orchestration engine is kind of the brain of a container infrastructure, and therefore we need an open orchestration standard that is interoperable in a way that it can be run in a development environment that might be small, might be the developer's laptop, all the way up to a large private or public cloud. And the way I describe an application for the orchestration engine to instantiate needs to be an open standard, needs to be interoperable. So what I do in one environment can be executed in another environment. And last but not least, I already touched on the example of a container registry. Standardized container images in a standard format now also create the opportunity to simplify the distribution of software. The distribution of software from one environment to another environment, or the distribution from a vendor to a customer, or from one cloud to another cloud for bursting or workload management. So the technologies that are necessary to distribute container images and consume them need to be interoperable so we can maximize the opportunity around standardization. Red Hat has been working with the industry and the community at large to drive interoperability against these 4 areas. And you might have seen earlier this year the Open Container Initiative and the Cloud Native Computing Foundation being announced to address many of these interoperability needs. Which gets me to products. I talked about autonomy, how this is defined, and there are many ways how containers can be brought into the enterprise. And typically, there's a need for choice between offerings that are very focused on just running containers to offerings that take on more tasks and capabilities than just running. In our Red Hat product portfolio today, we position 3 key offerings for running and managing containers at scale. At the left of the chart, you see Red Hat Atomic Enterprise Platform, which is an infrastructure offering to run and manage applications in a clustered environment across any supported environment, as we'll see in a minute. OpenShift Enterprise builds on Red Hat Atomic Enterprise Platform and therefore builds on all the capabilities in there, but now extends it by adding a very rich set of application lifecycle automation capabilities to accelerate and automate how source code becomes running applications in the data center or in a cloud, as well as the developer experience and the middleware services that developers would consume when they build their applications with the security across these 2 dimensions. So OpenShift Enterprise is a fully integrated platform for developing, managing, running, and securing applications. And Red Hat Cloud Suite now takes OpenShift Enterprise and integrates it with other technologies for managing multiple environments across hybrid cloud environments on top of private cloud technologies such as OpenStack as delivered by Red Hat Enterprise Linux OpenStack platform. Now what is common across all these platforms is portability for the applications. And portability at Red Hat is defined across 2 dimensions. There is portability across different environments. The environments that we have in the data center today or in IT today, and we predict we will still have 10 years from now. We have physical environments for bare metal workloads. We have virtualization and lots of virtualized environments. Many organizations are investing massively into building a private cloud to have cloud-like self-service capabilities within the walls of the enterprise. And we're increasingly also consuming or moving workloads off into public clouds. So all these payloads exist, and we need portability across them so that an application throughout its life cycle can live on any of these workloads. But that is only one dimension. The second dimension is on which platform are we running these containers? Because different applications, different teams might require different services from the platform, from the simple ability to run container to the ability to automate the life cycle to the ability to integrate actually with other services that might be running in virtual machines or in bare metal. So Red Hat also enables portability across these different platforms from Red Hat Enterprise Linux as a standalone OS all the way to Red Hat Cloud Suite as a completely integrated vertical solution that enables a private cloud inside the enterprise. If we look at the technology that is at play here, then I want to explain it on the difference between Atomic Enterprise Platform and OpenShift. A container platform needs to have at least 4 basic components. There needs to be a very secure and reliable container host operating system. In the Red Hat portfolio, this is Red Hat Enterprise Linux, which is the leading OS for containers, is the leading Linux offering out in the market. The container host also comes with a container API that drives the format and has the low-level primitives to instantiating containers and integrating them with the underlying resources that the operating system provides: compute, network, storage, security. In this case, we have integrated Docker as the technology to drive the format and also the runtime to instantiate and enable the container to consume services. Typically, as I explained, containers consist of multiple components and might span multiple hosts. So the orchestration capability is now connecting the capabilities for an application for all the instances of different containerized services across host boundaries, and at the same time exposes the APIs to management systems which can now interact with the container platform and, for example, launch or scale up and down applications or create inventories of what is running inside a container, etc. OpenShift now builds on top of these capabilities that Atomic Enterprise platforms, and on one hand provides services that are readily available inside containers from language runtimes such as Java or PHP or Python in certain versions, but also services that applications might consume in standalone containers such as databases or data grids or other services that application might consume like messaging. So these are basic containerized services that are now becoming available inside the platform for either building containers on top of that or just consuming inside the application. And OpenShift also integrates with the complete tool chain for a DevOps-like workflow and the experience for the developers so that with very few steps, a high degree of productivity can be achieved for developers and a high degree of automation can be achieved for code to travel through the software delivery pipeline with continuous integration, staged rollouts, and other capabilities that are increasingly becoming the norm for the rapidly changing, fast-moving systems of engagement. And of course, on top of these applications, on top of these platforms, I can run almost any application because we're now having the advantage of a unified container format that can carry almost any payload that we can run on top of any infrastructure. So that is really the technology view of these offerings. And when you think about a container platform, then you should think about assessing the capabilities of a platform against all these dimensions, because if you want to use it against an IT ops set of requirements and an application and developer set of requirements, you will need all these capabilities. So one important aspect that I talked about is the complexity. The complexity is inherent in a containerized infrastructure by the many container images that we will see. If we empower many teams to build and manage their own containers, then we will have lots of different containers. We want to enable them to be that flexible and run these containers and define them, but we have to hold them accountable for the things they now own, like security, like resource consumption, which translates to cost. So an important requirement for container in the enterprise is container management. At Red Hat, we're driving containerization into all our management products, and what you see here on this slide is a screenshot of CloudForms, our hybrid cloud management platform, which aggregates a view about a containerized deployment. It shows you the infrastructure view at the top with how many container hosts are running with which attributes to it. And it also gives you the more application-centric view as to how many containers and services are running, how many images are available in that environment, what is their state. So what you see is your more performance-oriented dashboard that shows the degree of saturation and load in this environment. CloudForms can also collect a lot of data about what is inside these containers, what is running there, and aggregate these views into integrated dashboards, as well as use that data for making decisions, for example, about where to place a container. But our technology vision for container management is to provide a fully integrated view on what is happening inside a containerized infrastructure, taking into account the infrastructure view that typically IT would manage with the tenant view, which is used by the application teams, but also enable the management tool, CloudForms, to make decisions based on policies, where to place certain workloads, how to process certain events, so that, for example, security can be managed at scale and a complex organization can still hold each other accountable and satisfy their overall policies. So this is our vision. Now, let's look at this in the real world. How can this look in the real world? And apologies for the slightly busy slide, but this is what the world is going to look like very soon. At the bottom of the chart, you see the 4 deployment footprints that I talked about: physical, virtual, private cloud, public cloud, on which you would run platforms. Right here, we offer many choices of platforms, and they're typically based on Red Hat Enterprise Linux, but target specific use cases. I talked about Atomic, I talked about Enterprise, I talked about Cloud Suite. So these are all platform choices that all can run containers. On top of these, they are effectively providing container hosts, which you see with a little invert L picture here, which enable the flexibility and scale to run workloads in containers. And now, above that, you see the containers which can carry either traditional applications or modern, which consume technologies from the top. So this is an architecture view. Now let's look at what happens in such an architecture view if one application suddenly has a peak in load. Suddenly lots of users are on an application. As you see, we can automatically react to this event and ask the orchestration engine at the container platform level to just instantiate more container hosts or provide more capacity to this application in the form of more containers. So we can automatically orchestrate more containers, and if we have the full integration with the underlying infrastructure, also more container hosts, so we can dynamically respond to that need, fully automated if necessary or manual, but without additional overhead within seconds or minutes, and provide additional capacity to serve these users. And when that load is no longer there, we can scale down. That becomes very easy with containerization, even for applications that are not originally built for that kind of scale. A second use case that is very relevant for the enterprise is a more security-centric view. As you see on this slide, there is a security issue that was discovered in PHP. So that becomes known. You might get an email from RHN, for example, or you might read about it somewhere else. Now, what does it mean for the enterprise? The security flaw now means we might have this security issue in our library of container images that we use inside the enterprise. So the first thing we have to think about is containers that are available, container images that are available for instantiation. We need to fix them. We need to change them. Red Hat provides the tool to do that with Red Hat Satellite or manual tools to easily absorb and consume such security fixes and update these container images, which are then used. At the next row below, we see the running environment view. Now we have to bring these containers that are now fixed into the running world, and that is fundamentally working differently in a container world than we might be used to it from a traditional world, where we are not actually patching the running instances. We are replacing the running instances with a patched version. And this is speaking to the immutability of container images and is one of the major advantages because it creates more standardization, less variety in what we are running versus what is available. So container registries and the ability to manage container at the point of distribution is one of the key concepts that enables containers to help managing security better than it was possible before. So now back to the architecture view in this use case. In the enterprise, we need to be able to respond to a security fix and take it into the container images and into the running environment. And we need to have the tools to do that, which begins with the insight as to where do I even have that issue. Remember, I talked about the security is defined inside the container. Here you now see why that is true, because you can only fix issues in your environments if you know what is actually running there in the first place. That's why we build out our vision across platforms, management tools, spanning different environments, all the way to the life cycles and enterprise value propositions of what goes into these containers in the first place. With that, I'd like to summarize what I've said. Containers for the enterprise are very, very exciting and deliver many, many benefits. It is about revolutionizing application delivery with an order of magnitude advancement in the flexibility, in standardization, in agility, which is what enterprise IT is looking for today. Containers delivered by Red Hat means a trusted environment in which applications become portable and with the ability to consume integrated solutions that address all the challenges that might be introduced by the rapid rate of change in these applications as well as the container technologies itself. With this, I'm at the end of today's session. Thank you very much for attending, and please watch out for additional notifications on other webinars in this series.